This lesson is about how to know if something is a linear function or a nonlinear function, and you will need to explain why you chose which one. So, if you take a look at the word nonlinear and linear, you can see that the word line is inside of it. So that means that a linear function forms a line when you graph it, and a nonlinear function will not form a line. So, in this first example, we have a line. So that is why it is linear. The graph forms a line. And then in the second one, you can see that we do not have a line. We have a U-shaped figure, and that's called a parabola, which you will learn about in high school math. And since it doesn't form a line, it is nonlinear. Okay, so when we have a graph, it's very, very obvious if it's linear or not. But many times we don't have graphs, we have tables or points. So let's take a look at an input-output table. And we have table 1 here. So in order to determine if it's linear, we need to know if the rate of change is constant or not. So let's write that down. So again, if a function is linear, it will have a constant rate of change. Now, remember the rate of change is the change in y's over the change in x's. And the change is with our symbol delta, so the change in y's over the change in x's. Remember, input is our x value and output is our y value. So we're going to look at the change in the y's. So from 9 to 16, that's a positive 7. From 16 to 25 is a positive 9. From 25 to 36, it's a positive 11. And from 36 to 49, it's a positive 13. Now if we look at the change in x's, 5 to 10 is a positive 5, 10 to 15 is a positive 5, 15 to 20 is a positive 5, and 20 to 25 is a positive 5. So the rate of change is 7 to 5 between these two. The rate of change is 7 to 5. Between these two, it's 9 to 5. And I can go ahead and stop there because I have found that it is not a constant rate of change. Remember, this word constant means the same. So this would be a non-linear function, and the reason is the rate of change is not constant. Again, I found the rate of change by finding out how much the y's change and how much the x's change, and it's y to x, the ratio of y to x. Let's take a look at table 3 there. So this time, the inputs are on the left, that's your x value, and the outputs are on the right. And remember, the rate of change is the change in the y's over the change in the x's. So the y's go up 2 here, they go up 2 here, up 2 here, and up 2 here. The x's go up 1, 1, 1, and 1. So now we take a look at the rate of change. We take the change in y's, which was 2, over the change in x's, which was 1. If we look at the next one, the change in y's was 2, the change in x's was 1. The next one, change in y's was 2, change in x's was 1. And the last one, change in y's was 2, change in x's was 1. So, because the rates of change are all the same, that makes this linear. What I would like for you to do now is flip your paper over and put one more example on there. So we are going to add our own input-output table. This goes on the back of your notes. So the input is our x and the output is our y. Oh, sorry about that. Let's say we have an input of 1 and an output of 5. Input of 3, output is 9. Input is 7, output is 17. Input is 9, output is 21. So I want to know, is this linear or nonlinear? And I want to know why. Okay, so what we're going to do is we're going to take a look at how the y's change. So this goes up 4, this goes up 8, this goes up 4. The x's go up 2, up 4, and up 2. So we need to now look at the rate of change. So the change in y's over the change in x's is 4 to 2. Here it's 8 to 4. And here it's 4 to 2. So are these all the same? So 4 to 2 simplifies. That's 2 to 1. 8 to 4 is 2 to 1. And 4 to 2 is 2 to 1. So that means it's linear. And the reason is because the rates of change are constant. Alright, so that was the end of the notes. What I'm going to do now is I'm going to put a table on these notes, and you need to go to Google Forms and tell me if this is a linear function or not, and explain why. So if the input is x and the output is y, we're going to have 3, negative 2, 5, 4, 9, 16, 10, 19. So I want to know if this is linear or nonlinear, and I want an explanation as to why. The Google form you can find at bit.ly/linear. All right, go do that, and you will be done until Tuesday.